Okay, guys, example number 2 here says, write an equation to represent the given relationship among integers. All right, so let's read this for a second. Let's just read what we have here, Jordan. It says the smaller of two consecutive integers. The smaller of two consecutive integers. Okay. So there, well, it doesn't have to be. Max just said n minus 1. But it doesn't have to be. It could be n and n plus 1. But which one's smaller? N. Okay. All right, so it says the smaller of two consecutive integers is, what does that mean? Equals, good. 5 more than 1/2 of the greater. Okay, well, let's break it down. Let's break it down. It says the smaller of two consecutive integers. Can I let that be the first one and this be the second one? N and n plus 1. So which one's smaller, Ian? N. It says the smaller of two consecutive integers is. All right, so that's the smaller is. 5 more, right, than 1/2 of, what does of mean? Times, thank you, Tara. 1/2 of the greater, n plus 1. Okay? Now, guys, let me say something. This is not hard. I mean, you guys can knock this out. However, we do have some fractions in here. Okay? Remember, we always simplify before we solve. So if I'm looking at the right side of this equation, I'm going to distribute. I'm going to just bring down my 5, and I'm going to get n over 2 plus 1 over 2 when I distribute. Everybody happy with that? And then on this side, I've got n. Now let me ask you something. Let me just ask you something. How many of you like working with the fractions? Yeah, me either. Really, right? It's just kind of confusing. How could I change this equation so that I don't have to work with fractions? Read. Oh, now Reed's going the decimal route. But I like this one. Let me show you this. Remember, I can do anything to an equation as long as I do it to both sides. Right? I'm going to multiply both sides by 2. Because I'm going to now the denominators will cancel out, right? So here's what I'm going to get. I get 2 times n on the left side is equal to, and then I've got to distribute over here, 10 plus, when I multiply the 2 times n over 2, the denominator just cancels out. I get 2n over 2, and that's just n. And then 2 times 1/2 is just 1. Now, I'd much rather work with that. That's much clearer, right? So Edward, now that I've distributed, I've gotten rid of the fractions, right? What would you do now? Remember, I always simplify before I solve. 2n equals n plus 11. Edward combined the like terms, which he should. Now I think I have simplified. Ben, where would you go from here? I'm going to get the variables together, just like Ben said. He said subtract n from both sides so he can get all the variables together. Because right now I've got variables on the left side and on the right side. Okay, so he's going to subtract an n from both sides and get them together. On the left, I only have n, and on the right, I've got 11. So now the smaller number is 11. The larger number is 12. Well, let's see if that's true. Let's just see if it's true. They said the smaller, okay, 11, is 5 more than 1/2 the greater. Well, what's the greater? So 12, right? What's half of it? 6. And 11 is 5 more than 6, isn't it? Beautiful. Beautiful. Great job, guys.